One side is amplified in the semiconductor and comes out the output stronger. Bill Shockley was working at home that day. Walter Brattain and John Bardeen decided to call him with the good news. But his response was not what they had expected.
Shockley had two emotions. One, he was very pleased because he knew how important it was, and I think he genuinely did like these two people. He was also stunned and angry and disappointed because he realized at that moment that they had done it and he had not.
That phone call from Brattain and Bardeen changed Bill Shockley's life forever. His friends said he was never the same.
And then there was this remarkable change in character and outlook. He became more ingrown, intense, and his friends saw less and less of him.
His subordinates had just invented the device that Shockley had been dreaming about for years, and they might get all the credit. He would have to do something to get back in the game and do it fast. On New Year's Eve, 1947, just a couple of weeks after Brattain and Bardeen demonstrated their new invention, Bill Shockley was attending a physics conference in Chicago. Ignoring the celebration, Shockley stayed in his room, impatient to put the ideas swimming in his head onto paper. He realized that Brattain and Bardeen's device would be fragile and difficult to manufacture. Shockley would take advantage of these problems. He would invent a better transistor. Brattain and Bardeen's point contact transistor worked this way. One input point, one output point, contacting the surface of the semiconductor. But as you can see, the points can loosen up, and the surface of the semiconductor can become marred and useless. Shockley had a better idea. Why not mimic the vacuum tube and create a 3 layer sandwich? This way we can move the input around to the other side, just like in a vacuum tube. So electricity would flow in the input and come out the output. And in between would be a third layer, just like the grid in the vacuum tube. A small electrical signal coming in the grid would influence a larger electrical current flowing from the input to the output. Voila, just like the vacuum tube. This was a brilliant idea because it made up for the shortcomings of the point contact transistor.
And all of this work he did and had it written down in his notebook and witnessed by fellow Bell Labs employees within 4 weeks of the, certainly within a month of the original invention. That was an extremely productive period.
Bill Shockley returned to Bell Labs from Chicago and told no one. He redrafted the idea at home, telling neither Brattain nor Bardeen, keeping them in the dark. It was an insult the two would never forget. The first crack in the harmonious team had been created, a rift that would widen and eventually destroy it.
Brattain and Bardeen essentially got pushed aside, and we're working on research into the surface, into the point contact transistor, that Shockley probably knew was a blind alley, a dead end.
My difficulties stem from the invention of the transistor. Before that, there was an excellent research atmosphere here. After the invention, Shockley at first refused to allow anyone else in the group to work on the problem. In short, he used the group largely to exploit his own ideas. I could not contribute to the experimental program unless I wanted to work in direct competition with my supervisor, an intolerable situation.
A tense situation became even worse when Bell Labs lawyers began writing the patents. Shockley insisted that he be named sole inventor of Brattain and Bardeen's device.
Shockley felt that what Bardeen and Brattain had done was derivative of his own ideas. He always thought that the light bulb always went off in one mind, and so he felt that his name should be on the patent all by himself or together with Bardeen and Brattain.
But Bell Labs lawyers decided to play it safe. Instead of applying for a patent on Shockley's broad idea of an amplifier made from a semiconductor, they focused instead on Bratton and Bardine's far more narrow device. It would be easier to defend.
And the patent attorneys recognized that that Shockley had played a role in this, but he actually had not been involved in that experiment. Therefore, they excluded him from the patent.
With the patents filed, Bell Labs decided it was time to break the secrecy and go public. But what would they call the new invention? They knew such an important device needed a really good name. Walter Bratton sought the advice of his old friend, John Pierce, an engineer who wrote science fiction stories on the side.
They'd been describing it in descriptive sentences, or a couple of really crazy ideas were put forward. But Walter wanted a meaningful but above all, a name that fitted with things. And I provided that.
Pierce realized that the new device worked by varying the resistance as current was transferred through it. Trans resistance.
Then the name should fit in with other things such as varistor and thermistor, which were the names of other devices. And from the fitting in with other things and from the idea of trans resistance, I suggested the name Transistor.
Gentlemen, may I ask you to take your places?
And that's what it became. Publicity photos recreating their historic experiments were staged in Walter Bratton's old lab. But as the three men took their places, Bill Shockley sat down center stage in Walter Bratton's seat. Nick Holonyak once naively asked John Bardeen whether Bratton liked the photo.
John made a pained look at me, and he vigorously shook his head, and he says, "No. That's Walter's apparatus, that's our experiment, and Bill," and he didn't say Shockley, he says, "Bill didn't have anything to do with it."
Bratton later wrote Shockley, expressing his frustration over the picture, the patent, and being cut off from working on the new device.
Dear Bill, a few remarks after sleeping on our talk of yesterday. It appears to me that the discovery of the transistor has ruined the best research team I ever had the privilege to work in. I think there was an effort in the beginning to give the credit to the group as a whole. The patent department squelched this.
Bell Labs finally broke its silence, and on June 30th, 1948, Ralph Bound, director of research, made his proud announcement to the press at Bell Labs' old Manhattan headquarters.
Is a device that can amplify electrical signals as they are transferred through it.
The announcement got very little public attention. The New York Times buried it on page 46. Time magazine placed it in a small section in the Science of the Week. Even engineers thought it was a nice device, but for something that did not need replacing, the vacuum tube.
The people I was with in the tube lab laughed, and they said, "That's just a crystal set thing. That's a joke. That's just some little wire sitting on top of a crystal, and that's like our old crystal sets. That's not going anywhere. If you want to do real electronics, you go down to the storeroom and you get some vacuum tubes, capacitors, resistors, inductors, transformers, and go to work."
But one man realized its potential.
I think Shockley understood its implications more than any living human being did. He was predicting things that came true 20 and 30 years later, and nobody else ever came close.
Soon, there were others. In a bombed-out department store on the other side of the world, two Japanese engineers saw great business potential in the new invention. When Masaru Ibuka and Akio Morita heard that Bell Labs was going to license the technology for the transistor, the entrepreneurs realized they could use it to make transistorized radios.
They recognized the importance of the transistor to things they wanted to do, and they did a wonderful job of building up the